Today we're going to look at Unit 10, Section 2. Again, we're focusing on transformations. And today we're going to look at dilations and symmetry. Line symmetry, rotation symmetry, and point symmetry. Dilation is the enlargement or shrinkage of an object, determined by some scale factor. Remember, scale factor is a ratio. So here's our original. This is an enlargement of the original. These are similar. They're similar. This is the original. This is a shrinkage. Again, they are similar. Dilation is done with a scale factor, in the same way how similar shapes work. So a scale factor of 3/4. That would be, if we took an object, scale factor of 3/4 would make it smaller by 3/4. Scale factor of 5, if we take an object, it means we're increasing its size by 5. That may not necessarily be 5 times, but it's the idea. It's increasing in size. Scale factor of 1, the shape is the same size. It's a 1-to-1 ratio. So let's look at a scale factor done graphically. We have these points, and we're applying a scale factor of 2. So we're increasing its size by 2. So I'm just going to multiply my coordinates by 2. 0 times 2, 0 times 2, 2 times 2, 0 times 2, 0 times 2, 2 times 2. Oops, that should be a 4. So my new points, 0, 0 is right there. 4, 0, 0, 4. There's our new shape. Again, this new shape is an enlargement. It is similar to the original. Scale factor of 1/2. In other words, it's being shrunk. So times by 1/2. 3, 4, -2, 1, 2, 0. 3, 4, -2, 1, 2, 0. And that's the shrunk image. Again, these are similar. That's the idea of dilation. You enlarge or shrink an object based on a scale factor. Line symmetry. Line symmetry is the idea that a shape can be folded in half across the line and still be the same. So this triangle, I can fold across this line and it's still the same shape. When I fold it, it goes on top of this. Now, how many lines of symmetry exist for a shape like this, which is a regular pentagon? Well, I can fold here, so that's 1. I can fold here, that's 2. I can fold here, 3. I can fold here, 4. I can fold here, 5. Regular pentagon has 5 lines of symmetry. What is the line of symmetry for this shape? Now we're actually looking for an actual equation of a line. Now, just glancing at it, this is shorter than this and this. Now, a little bit of thought, I can tell, look, over 3, and then down 8. So that means this and this are congruent. So what I can actually do from this is determine, since those two are congruent, I have a isosceles triangle. I can draw a line of symmetry right down that line. This can be folded over here. Well, that line is x equals -1. That's the line of symmetry for this shape. Rotational symmetry An object can be rotated x degrees and still be in its original shape. So I take this shape, which is a square, I can rotate it, look. 90 degrees, it's still the same. I can rotate 90 degrees, still the same. 90, still the same. 90, still the same. So a square has 90 degree of rotational symmetry. Now an octagon, here I can rotate 90 degrees and it'd still be the same, but I have even better symmetry than that. I can rotate and it's the same. That's not 90. I rotated it less than 90. Well, how much did I actually rotate it by? Well, let's figure it out. It's got 8 sides. Just like a circle adds up to 360 if we think about it that way. 360 divided by 8, 45 degree rotational symmetry. I can do the same thing. Here, 360 divided by 4, 90 degree rotational symmetry. I can do that for any regular polygon. I can take 360 divided by a number of degrees, and that's its rotational symmetry. Point symmetry. The idea of a point symmetry is that an object can be rotated 180 degrees. In other words, flipped around and still be the same. If I take this and rotate 180 degrees, this part ends up here, well this part ends up here. It looks the same. I rotate it. This one too. I rotate it all the way 180 degrees and it's the same. That's the idea of point symmetry. That's everything we're going to cover today. We'll see you next class.